So before we jump on to this topic, I want to take a moment and think about everything that we have learned till now. So you can close your eyes, think about the temperature, the idea of heat, idea of specific heat capacity, latent heat, and change of state. Please think about all of this because we're going to make use of it and understand this particular thing. It's a very simple thing. All we are doing is taking up an ice and melting it and boiling it actually. So we're converting an ice which is at minus 30 degrees Celsius to steam which reaches to 120 degrees Celsius over here. So you need to pause as of now. Look at the graph actually. Let me not tell more than this. I want you to think or read through the graph more than think. I want you guys to read through the graph. Understand whatever you are capable of. Understand through the graph. It's important that you learn how to read the graph. So first thing is what we have to do is we have to understand what the graph is about. So what is the graph is about? It's about heating curve. So heating curve of ice to steam. So that's the heading. Then we have to go to the x and y axis. Along the x-axis, what do we have? Yes, we have the temperature. And along the y-axis, what do we have? Energy added. So this unit is in joules. This is in degrees Celsius. Now let's move on. Let's go step by step and let's make it very simple. So what's happening in the first part? Oh yeah, by the way, there are 5 steps. Okay. So overview, process involves 5 energy steps. So 1, 2, 3, 4, 5. I think that's a very basic thing. It includes temperature change to phase change, right? So we have temperature change and phase change. Okay. So that's what I want you guys to analyze. Where is this temperature change and where is the phase change? Temperature change is here, here, and here. So that's your temperature change. While your phase change is over here and here. So please understand which part is temperature change and which part is phase change. Temperature change is over here, temperature change is over here, and temperature change is over there. Phase change is over here and here. Right? How do I tell it's phase change? See, can you see the graph? So what is this temperature? Does it change or is it constant? Yes, temperature is fixed because this is parallel to x-axis. That's how I'm able to tell that is phase change. Right? Only in phase change we see this. This means temperature change because the temperature is increasing. It's moving from 0 to 100 actually. So the very first thing is your temperature increase. So basically this part is to do with your ice increasing the temperature. This part is to do with, right here, this part is to do with what? Phase change, that is the ice is becoming water. And at this very point, the last bit of ice becomes water. And this has to do with your water temperature increase. And this is where the temperature, all molecules have reached 100 degrees Celsius. 100 degree Celsius. And from this big range, so what does it mean? Okay, in terms of energy, we'll discuss later. So this is where your water is converted to steam. Water is converted to steam. And this point is where the last bit of water molecule in liquid state becomes steam. So this is the last bit of water molecule. The last liquid to convert to steam. And post this particular graph is wherein the steam is increasing the temperature. Okay, so you can pause and have a look for a second. I'm going to erase this actually. Now let's look at the energy. So we looked at the phase and temperature and everything. We looked at y-axis. Let's look at x-axis. Which needs the highest energy? Yes, a phase change. Which phase change? Over here. For this particular scenario, this has the highest energy, right? It consumes the highest energy. Phase change over here, that is water to steam, consumes the highest energy. Which is the lowest? Of course, technically I can make this go this down and this value will increase, but just for the sake of discussion. Here the lowest energy consumption is by the steam and temperature increase, right? So the last and the first bit, and your intermediate. So between your ice melting and ice reaching a boiling point, which consumes more energy? Clearly, water increasing the temperature. So when you heat the water, compared to melting an ice versus heating the water to 100 degrees Celsius. So heating the water to 100 degrees Celsius takes more energy. Okay, one last question. We're almost done, and then I'll show you guys the textual content. What is the energy needed for phase change? That is liquid to steam. What is the energy needed? What is the numerical value? It is around 2400. That's what I can guess from this. Actually, you have actual value. So 3070 minus 815. So if you subtract these two values, you'll get the phase change values for this particular scenario. Right, guys? So this is pretty comprehensive. So let's move on. Okay, using specific heat and latent heat. Oh yeah. Next is we'll talk about when to use specific heat and when to use latent heat. That you guys can tell. So this, I think I'm done. Please tell when should I use specific heat and when should we use latent heat. Right? Phase change. That's your latent heat and this is your specific heat. Okay, I think we are done. So step by step energy change. So state change, we have heating ice. So we have change in temperature. Then melting ice to water, change in state. Then we have heating water from 0 to 100, change in temperature, boiling water to steam, change in state again, heating steam, change in temperature. So here, sorry, I've used a different representation. So instead of C, I've used S over there. So you have your specific heat capacity values of ice, water, and steam. So you can see there are different values. Again, instead of C, I've used S. And this is your latent heat. So these are the formulas that we have to use. Okay, symbol, yeah, I have specific heat of ice. I've mentioned it over here. And if you guys are interested, this is to do with water. So now I want you guys to tell which has the highest value. So latent heat of fusion. All right. Latent heat of vaporization. Why? It's 10 to the power of 6. Okay. Always start with the exponent part, not the number part. So that's why you take a lot of heat to boil a water. As simple as that. To convert it to steam, you need a lot of water. And that's why your energy like coal-based energy or fuel-based energy or nuclear power energy has to be spent so much of money on it, That's why the energy cost is so and so on and so forth. So you can take the discussion in many direction just with this slide, honestly. Then what else? Heat required. I just stated the values. Okay, yes, there's nothing much I can add from all of this, honestly. I think this graph is good enough, and if you're interested in doing your own thing, I'll show the other values. That is, you can see the other values I'll be showing.